Hi everyone, this is Malik. Uh, this is this tutorial is about how to design a digital uh, DC ammeter using PIC microcontroller. So in my last tutorial, I was talk about a digital voltmeter using PIC microcontroller, but in this video lecture I'm going to talk about DC ammeter using PIC microcontroller. In my upcoming lectures I will also talk about AC voltmeter and AC ammeter, but in this video lecture I am also going to talk about DC ammeter using PIC microcontroller. As you know, DC ammeter is used to measure current, DC current. It can only measure DC current. I assume that you know how to use a DC ammeter or how to use ammeter in DC circuits. For example, if you have a 10 volt battery and you connected, for example, you connected 10 ohm load here, and you want to measure current through this 10 ohm resistor. What you do, you simply connect a ammeter. You simply connect ammeter in series with this circuit, and this ammeter will give you the current of passing through this resistor. So you maximum time you deal with analog type or digital type of ammeters, and you must be wondering how you can design your own ammeter using a PIC microcontroller. If you ever wonder about it, so your curiosity ends here. In this lecture I'm going to discuss in detail how to design a digital DC ammeter. First of all, to measure current in this circuit, you have to have some kind of shunt resistor. Let's talk about first of all, let's talk about methods in which you can measure current. There are 2 to 3 methods. First method is shunt resistor, and the second one is current transformer, so in case of shunt resistor, what you do, you simply connect a shunt resistor in the circuit of very small value, and you measure a voltage across this resistor, across shunt resistor, and as you know, you can only measure voltage with the help of microcontroller. And when you connect a shunt resistor here of very small value, so what will happen, for example, you have connected a 0.01 ohm shunt resistor here, and this is actually a ground. So we measure a voltage across this shunt resistor with the help of microcontroller. For example, this input is given to a microcontroller, and we need some extra circuitry to give this input to microcontroller. I will talk about it later. So you measure voltage across this shunt resistor with the help of microcontroller, and you can use Ohm law to calculate current. As we have measured voltage with the help of microcontroller, we already know the value of resistor, so we can use Ohm law in our programming to calculate current. So this is the one method. Let me tell you how you can use this circuit. For example, we have a 24 volt DC supply, and here is our load, and we want to measure current through this resistor. So what we will do, we will simply connect a shunt resistor here, and for example, this is ground, and we will measure for example, value of the shunt resistor is 0.1 ohm, and we will measure voltage across this shunt resistor with the help of Okay, so this input will be given to microcontroller will measure voltage across the shunt resistor with the help of analog to digital converter. If you want to know how to use analog to digital converter in microcontroller, you can visit my website microcontrollerslab.com. I have given a link of my website in the description of this video. So as you know, we have measured voltage, and we already know the value of resistance, so we can easily calculate current with the help of Ohm law formula. So this is the method of shunt resistor. So let's talk about a current transformer. So what happened in case of current transformer? You simply connect simply, for example, if this is our circuit, and we want to measure for example, this is a 10 ohm load and we have connected 24 volt, and we want to measure current across this circuit. So what we do is simply connect this circuit with CT, current transformer, and current transformer will give us for example, we connect a current primary of current transformer here, and current transformer will give us output in the form of voltage, and we can measure this voltage with the help of a microcontroller, and by using turns ratio, or respective values which will be given on CT data sheet, we can calculate current. For example, if your CT ratio have 100 ampere to 5 ampere ratio. For example, CT will give us if we have 100 ampere current at primary side, CT will give us step down current of 5 ampere at the output, and it will not give us output in the form of current, it will give us output in the form of voltage. But relation between voltage and current must be given in data sheet. So for example, if a relation is 1 ampere is equal to 1 volt, so if we measure 1 volt with the help of microcontroller, so it's mean voltage at the secondary, if we measure 1 volt at the output, 1 volt at the output with the help of microcontroller, it's mean current at the secondary side is 1 ampere. So what will be the current at the primary side? So we can use this relation to find our multiplication factor. So in this case, multiplication factor is 20. So it means if current is 1 ampere at the primary, at the secondary, what will be the current at the primary? It will be 20 ampere. So you can use a current transformer. So you can consult with any current transformer data sheet to know about its turn ratio or its voltage and current relationship. There is one more method, one more sensor which is used to measure current, that is Hall effect sensor. There are many Hall effect sensors available in market. The most famous one is ACS 712, because it works on the principle of Hall effect, and it can measure DC as well as AC current. It is beyond the topic of our discussion to talk about Hall effect sensor, but still you can use Hall effect sensor to measure AC and DC current. What will happen if you connect Hall effect sensor in series with your circuit? It will give you output in the form of voltage, and relation of voltage and current is given in the data sheet of ACS 712. So you can use this relation to calculate current with the help of measured voltage. For example, if you have measured 2 volt with the help of microcontroller, so there must be a relation in the data sheet of ACS 712 to convert this voltage into current. So there are many sensors available in the market to measure AC and DC current, but in this article I will discuss only a simplest method to measure DC current. So for example, we have a microcontroller here. I'm using mu sign for microcontroller, and we want to measure DC current and want to display it on LCD. So for example, if we are using 16 cross 2 LCD. So what we will do, we will use, for example, this is our circuit and we are using 12 volt, and this is our, for example, this is uh, 6 ohm load. So for example, we are using a shunt resistor here, and value of shunt resistor is 0.01 ohm. So this is ground. So what amount of current will flow in this circuit? As you know, V is equal to IR, so I is equal to V by R. Input current is input voltage is 12 volt, and load resistance 6, so 2 ampere current will flow in this circuit. Why I'm not using a shunt resistor value? Because this is too small, it will not make any difference. So so it means what will be the voltage drop crosses this resistor. So voltage drop cross this resistor is equal to V is equal to V2 minus V1 divided by R. So sorry, this is the formula current. So sorry. So what will be the voltage drop across this resistor? It will be equal to we know the current, we know the value of resistance, so it will be equal to 0.02 volt, or in other way it will be equal to 200 millivolt. So microcontroller can easily read 200 millivolt. So if we read 200 millivolt with the microcontroller, we can convert it back. If we can convert it into current using again Ohm law. So for example, we have connected this input with the microcontroller ADC. Okay, remember voltage across this resistor can never be greater than 5 volt, because there are first of all, why voltage should not be greater than 5 volt? Because it will create losses in the circuit, and another issue is microcontroller cannot measure voltage greater than 5 volt. Okay, so it is always recommended not to use a very high value of resistance, such as shunt resistance, because it will create losses. Yes, you know the formula of losses is P is equal to I square R. So it will create losses here. For example, current is of 2 ampere, 4 multiplied by, if you are using 1 ohm resistance, so it will be 4 volt will be lost here in the form of field. So if you are using only 0.01 ohm, so it means it will 0.04 watt. So there will be a loss of only 0.04 watt. Okay, so this is the basic overview of how you can design digital DC ammeter using PIC microcontroller. So another thing which I want to discuss is that there are some limitation with the shunt resistor. Number one limitation is you cannot measure high current. Why we cannot measure high current? For example, if we are measuring 100 ampere and we are using a shunt resistor of 0.01 ohm, so in this case current value is I. For example, current is equal to 100 ampere and shunt value is 0.01. so what will be the losses in this case? 100 का square multiply by 0.01, so it will be 100 watt. That is too large losses. So so we cannot measure high current with the help of shunt resistor because it will create a lot of losses. Number two, it will create heat in the circuit, will be dangerous for other components of the circuit. And another reason we can't use shunt resistor for high currents. It is usually recommended to use shunt resistor for current of around 5 to 1 to 5 ampere, because if current is more than 5 ampere, it will definitely create losses in the system. So shunt resistor method is suitable only for low current measurement circuits, and if you want to measure high current, you should use current transformer, Hall effect sensor. I recommend you to use ACS 712 because it is cheap, and we can measure both AC and DC, and it has more accuracy as well. So now let's talk about a circuit diagram of DC ammeter using PIC microcontroller. So I'm using pic16f877a microcontroller in this project. So let's discuss about it. So for example, there is some issue. For example, we sorry for disturbance. Let me get a complete picture of DC ammeter using PIC microcontroller. So here it is. As you can see, in this circuit we have connected a DC battery of 30 volt, and we have a load of 40 ohm, and we are using 0.47 ohm shunt resistor. So this is shunt resistor. Okay, and this is our load, and this is the circuitry for oscillator, and this we have connected LCD here, and we are using pic16f877a microcontroller. So first of all, we are using 0.47 ohm shunt resistor. So what will be the maximum current in this circuit? So current will be equal to I is equal to input voltage is 30 and resistance is 40. So maximum current will be 3/4 ampere. So it will be less than 1 ampere. So simply we have connected given this input to the microcontroller with the help of why I have connected 100 k resistor here, because it will prevent a high current to flow in this way, because because if you connect it directly with the help with the microcontroller, there might be chances that microcontroller may offer a lower resistance than shunt resistor, and current will start flowing this way, and it will damage our microcontroller. And we have connected another protection component, that is xenon diode, because it is 5 volt xenon diode, and it will prevent more than 5 volt to pair across ADC of microcontroller. If you want to read more about ADC, how to use ADC, I recommend you to go to my website, microcontrollerslab.com. Here is a link of my website, microcontrollerslab.com. And if you don't know how to interface LCD with the PIC microcontroller, you can also find tutorials on my website about how to interface LCD with microcontroller. So this is the basic circuit of a digital ammeter using PIC microcontroller. So now let's discuss about programming part of digital ammeter using PIC microcontroller. So let me remove it first. So to design to write code for digital voltmeter, first of all what you have to do, you have to measure voltage across shunt resistor with the help of ADC. Second thing, you should know how to interface LCD with microcontroller. Third thing, you should know how to use microcontroller, or how to connect necessary components with the microcontroller, like crystal oscillator, reset crystal, and oscillate and reset, etc. You should know how to use Ohm law to convert measured voltage and known resistance into current. So these 4 things are necessary to write your code using pic16f877a microcontroller. So now let's discuss the programming part of pic16f877a microcontroller. So this is the programming part of digital DC ammeter. So these are the lines used to define LCD. For this S set bit tells we have connected LCD RS pin with the RB4 pin of microcontroller, enable pin with RB5 pin of microcontroller. You can read more about it on my blog. So let's come to the main part of the code. So main part of the code is that we have defined port A as an input and port B as output, because we have connected input of shunt resistor with port A, and we have defined port B as output because we have connected LCD with port B. These are the built-in functions. I have written this code using microC. So these are the built-in libraries of microC. Here we clear the LCD, we have turned off the cursor of LCD, and here we cleared the LCD, and now we are displaying digital ammeter on first row of LCD, and now we are using a delay function to count on delay for 1 second. So here we are using a variable current to store the value of ADC which microcontroller read, and in this statement we are converting measured voltage back into current. So what we are doing here, first of all, to in case of ADC, we measured value of ADC converted back into voltage by multiplying it with 5 by 1023. This is basically a resolution factor. You can read more about how to use ADC on my website, and so it will become basically 4.88 millivolt, or it will become 0.00488. So I am using here, why I'm using 4.89, because over this is our multiplication factor. For example, if I write it this way, current multiply by 0.00488, and now we basically this will be the output, this will be the voltage, and now we can convert voltage back into current using Ohm law. I is equal to V by R. We have measured, this is actually will be the voltage, and to convert voltage we have to divide it by 4.7 0.47. So so actually this will be 47 only. So 47, and we have multiplied it with by 100, so it will become 4.89 multiplied by divided by 47 and multiplied by current. So this will give us the current, and using this function we are converting current into string, because we can only display string on LCD, and this is all just for to display current on LCD. So this is all about digital DC ammeter. I have made this video just randomly, and hopefully in my upcoming videos I will present you more more good information, because I haven't prepared for it. So thanks for watching this video. Allah Hafiz.